Awesome. Well, thank you all for joining. I'm Dave Bergstein. I'm Director of Product at Pinecone, and I'm joined by James. Say hi. Yeah, we're excited to talk about the February release for Pinecone. I want to say that this is a big deal in many ways. This was a massive effort for us at Pinecone because we rewrote a significant part of our code into Rust. So a pretty foundational change, to revisit so much of what we have at our core and to revisit so many of those decisions and design decisions that were made in our earliest days. Some people questioned, why now, right? I mean, we have great traction in the market and no shortage of feature requests, but we see that this is really just the beginning. And for everything that we aspire to build on top of Pinecone, we wanted to have the best possible foundation. And now is the time to go ahead and make sure that we have that rock solid foundation. And so we do. We added the console on top, which is very visual, and you can see. And we got a number of important benefits that we can walk through right now, including performance, predictability, and control. So starting with performance, it wasn't really our primary goal to necessarily, again, this is about a foundational change and how Pinecone is built. But we're very proud of the performance gains that have already come along with it, and we see many more to come in the future. Looking at performance, one of the things that's most notable that I want to call out is the fact that performance scales much better as you go to larger indexes and greater number of pods. And so if you look at P1 here, you can see that the curve, the solid blue line now, nicely flattens out so that our latencies are, for P1, this is showing just above 100 milliseconds. And that stays nice and steady even as you go to extremely large indexes. I also want to point out, the plot here, it says performance optimized. That's because it's our P1 pods. We have P1, which are more performance optimized, and S1, which are more cost optimized for larger indexes. But even within the P1, this is with the maximum number of vectors stored per pod. And so in that way, it's kind of like a worst case in some sense, because you can always improve performance even further by lowering the number of vectors per pod. But what we wanted to show in this curve was, suppose you filled the pod, right? You went all the way to 1 million vectors per pod, and you didn't do any filtering. I think we've talked before about Pinecone has a wonderful ability to filter based on metadata. And when you do that filtering, you get better performance too. But this is not assuming any filtering. So we kind of wanted to go worst case, say that there's no filtering and say that the pods are full. And in fact, the latency is still around 100 milliseconds, and it stays that way as you add many, many more pods. The truth is on looking to S1, it's even better, right? You can see here the curve flattens out at around 500 milliseconds. Again, this is kind of a worst case, assuming that you're filling the pods with 5 million vectors. If you did less, you would get better times. And this is without any filtering. If you did filtering, you'd see even shorter latencies. And so again, this is something that we're very excited about, that we've managed to provide. And I see it as really part of the fact that by revisiting some of those design decisions, moving into Rust and ironing out some of the kinks, we've built a system now that can scale to billions of vectors, and we have customers already on billions of vectors, and we're excited about that. The other key part is predictability. So I know that a number of people have talked about, or customers have told us that they really want a better way to be able to predict how many pods they should be using. And so often people come to us and we're happy to answer those questions and walk through what makes the most sense. But now, even easier is that we have the usage estimator, the calculator right on our website. And so that you can compute, based on your number of vectors, dimensions, the pod type, and see how many pods you should be using. The other thing is that performance got a lot more predictable in the sense that P50 and P95 values are now tightly coupled, only, say 10 to 20% different from one another. And that's a nice change. What we were seeing before was that due to some variety of edge cases, it was, occasionally there were some latencies that were longer. And so that was causing the P95 to look worse or to be worse. And so we're happy that we've addressed those in our reworking of things and in our rewrite. And so now we see nice predictable performance. P50, P95 are much closer to one another. And also upsert. This was another pain point we did hear from people, is that upsert, at times, if you were upserting too fast, it was throwing errors. We could only manage with a certain amount of upsert volume. Now that's been resolved in many ways. One, upserts go much faster than they did before. And then number two, you shouldn't be getting the errors. It shouldn't be taking vectors faster, really, than we can handle. And then three, if you actually reach the limit or start to approach the limit, you'll get a nice message back saying that you're at your limit for this pod and for this index, and it can't accept more vectors. But of course, you can always just delete vectors then to make more room. And so all of this works in a much more predictable way without some of the errors that were occurring before. And then lastly, control. So the console is another big update. I mean, I talk so much about the fact that we wrote so much code into Rust, but I don't mean to minimize the work that we've done on our console. And we heard feedback about how we can make it more useful, how we can make it easier to navigate, to provide things in the menus and the places that people kind of expect them. And so we've done all that. And we've also provided more choice now in terms of regions and providers. So we're on AWS, we're on GCP, we have 3 regions, and we expect many more to start coming. And so we're excited that we can provide this greater level of control through the console and through the regions and cloud providers. Okay, so with that, I'm going to pass it over to James to give us a spin.
Thanks, Dave. So I'm just going to share my screen. Okay, let me know when you can see it.
Yeah, I can see it.
Yeah. So I'm just going to go through an example, going from actually predicting how many pods we need for a use case to setting up the index and actually querying and seeing the sort of speeds you can get in terms of how fresh your index is. So over on the pricing page on Pinecone, we can come down here to find the usage estimator. And we have the 2 different pod types that Dave already mentioned. So in my use case, I want to use about 8 million vectors. So I just enter 8 million here. The dimensionality is correct here. So if I use a performance optimized index, I know that I need a minimum of 8 pods, and I'll get this sort of latency, and this would be the cost. I can switch to storage optimized to see what that looks like. So because it's a storage optimized pod, you need much less, but the performance might be a little bit slower. So in this case, I'm going to go with performance optimized. So I know I need to create an index with 8 pods. So I go over to my Pinecone console. I can come over to my project here. And I already have the demo index running here, but I'll just go ahead and create a new one so we can see how that works. So I'm just going to call this demo 2. Dimensionality, I want 768. The metric, I'm going to go cosine, and then we have the pod type here. So if I go back to the pricing page, I can see, okay, I wanted the P1 pod. So I'll come here, P1, that's selected. I can switch to S1 if I want to, but I'll stick with P1. And I wanted to use 8 pods. So I create that index, and that would take a moment to initialize. But we already have this index here. Now I can go into here and I can take a look at my index details. So I can see I'm using P1, I've got 8 pods as we already created, and I've got slightly over 8 million vectors here. So that's roughly where I wanted my use case to, or roughly where I expected my use case to be. So I can come over to this demo, and over here, just need to make sure everything is installed. I come down here, and the first thing that I need to do is actually connect to the demo index. So I use my API key, which I can find in the API keys over here. And I'll just run that to initialize my connection to Pinecone. We initialize our connection to the index. This is, typical the Pinecone syntax, which we would usually use. Here, what I want to do is I want to query my index with just this query here. So Python is a popular programming language. So obviously, first thing I do is convert that into a query vector. I'm going to use sentence transformer for that. And then I come down here, and once that model has actually loaded, which may take a moment, I can encode my query into a sentence vector. So I'll leave that to download for a moment. Okay, so let's download the model. And what I'll do is encode query vector and query. I'm going to include metadata. Inside the metadata field, I've included the original text so that I can just very quickly see what we're returning. Okay, and as expected, the model or the vectors are working. We're returning a lot of relevant context. Now, in here, we're returning these 5 examples, and we have our IDs here. So it's IDX, 0x, we have 1x, 2x, and so on. So I'm going to make a list of those here. And what I'm going to do is delete those vectors from our index. I'm going to wait for 100 milliseconds, and then I'm going to query and see if we return those same results again. Now, when I was testing this, the majority of the time I didn't need this sleep at all. But in maybe 1 out of 5 times, occasionally one of those vectors would still be there. So that in that case, you're seeing almost instant, or not quite instant, but very close to instant update of the index, which for me, I was super impressed with and didn't expect that at all. But just to make sure it actually has time to refresh for the demo, we're going to wait for 100 milliseconds. So here we can see we're not returning any of those. So wait 100 milliseconds, and already all of our IDs have been updated. All of our vectors have been updated. We have none of those ID X, 1, X, and so on. So what I'm going to do is pull all of the sentences that we got before. I'm going to encode them. And this time I want to upsert them and wait 100 milliseconds and query again, see if it updates in time to show those relevant queries. Okay, so straight away we see we have 0x, so the ones from before that we deleted, and then we've just upserted again. We have 1x, 2x. So within 100 milliseconds, our index of over 8 million vectors has actually updated, and we can query and see those updates in no time at all. So yeah, that's the little walkthrough there. Now I think I'll pass back over to Dave.
Yeah, thanks. And I'll say, I think for some of you out there, I've said before, give it a few 100 milliseconds because I wasn't exactly sure where that boundary is. I know it's almost instant, and wonderful to see how well it works at even 100 milliseconds. Yeah, so I guess with that, I guess, Sophie, do we want to open it up for questions?
Yeah, definitely. If anyone that's attending has a question, feel free to put it in the chat or unmute yourself and share. I'm also going to look through some of the, see if any of our community members or Twitter followers had any questions. But yeah, obviously priority to folks who are already here.
So with Greg's question on the demo saying internal beta, is this live? Yeah, it is live, and the internal beta is just referring to our internal beta for version 3, which I was running on. In terms of performance, it's exactly the same as the outward facing v3.
So I think we have a question on how we improve things foundationally, and I want to say that I don't think I'm the best person to answer dive into all the technical details on what exactly we did with our move to Rust, but I know that Bram, our VP of engineering, is preparing a blog post. And I think he's going to dive into much more detail about what we did. I'll say that I think anytime you revisit a code base, you always see opportunities for improvement, and that was certainly the case here. But there was also, some critical design decisions that I won't go into here. And also, Rust is, in moving to Rust, the engineers took a hard look at memory management and really how to have a very tight control over how Pinecone organizes its memory and how it controls its memory and how it releases memory. And all this, has been a big part of the foundational change.
The demo notebook isn't public at the moment, but we'll share it after this.
Doesn't look like there were any Twitter community questions about this in particular. So if anyone here has more questions, we will leave the floor open for a while longer. Yeah, thank you so much, James and Dave.
Yeah.
Thank you.
Yeah, thank you.